2017 was Cumulative Update 4 that came out last month. And there are a couple fixes in Cumulative Update 4 related to Query Store. So it's always a good idea to be on the latest version when you can. And if you're running Azure SQL Database, Query Store has been enabled by default since the end of 2016, so for well over a year at this point. So one of the things that I often get asked when I start talking about Query Store is who should use it? And the first thing to know is that you don't have to be an expert in performance tuning in order to use Query Store. In fact, when they were putting this feature together, they designed it, they made it so that anyone could go in and find what's running poorly or what's running most often or what has regressed. So it's very easy to use even if you haven't been tuning queries in SQL Server for years and years. Now if you if you've been looking at query performance in SQL Server for ages, when you start to understand what Query Store is and what it can do, you're going to start to think of all the other things for which you can use it because it's capturing so much important and essential information when we talk about performance tuning. So some details that are important to understand about this feature. First, it's enabled for your user databases, and it's something that you're enabling per user database that's essential in your environment. And one of the things that I get asked a lot is some of you might have just a few production databases. Some of you might have hundreds or thousands. And people will say, well, do I enable it for all of them? And my response is, well, if it's a production database, then I assume it's important and performance is important. So I would say yes. But if you're concerned, if you're not quite sure how this is going to go, then my recommendation is that you start with the most important databases in your environment, the ones that either cause you the most trouble, maybe they're important because they take up a lot of your time, or maybe they're important because their performance is absolutely essential. But if you want to start small and ramp up, that's totally fine as well. But you enable that per user database, and that data for Query Store gets stored in internal tables in that user database. So just like we have sysobjects or sysindexes, right, those internal tables, there are tables that store the Query Store data, and it does exist then in the primary file group. And those are exposed through system views that you can then query. And so you can't enable Query Store for master or for tempdb. You can enable it for MSDB, and theoretically you can enable it for model, but you're not running queries against model, hopefully. If you enable it for model, then that would mean that any new database that gets created on that instance would pick up the setting for Query Store like it would for any other database setting that you have configured in model. And so it could be enabled by default for new databases. That may be what you want. It may not. In order to look at that data that's stored in those internal tables and then exposed through system views, you have to have the view database state. And one other feature of Query Store is that it allows you to force a plan for a specific query. And in order to do that, because that's pretty powerful, you need to be the DB, you need to have DB owner. Now, if you have an availability group, you might start to think about, well, what happens on my secondaries? If I have readable secondaries that I'm querying against, what happens there in terms of Query Store? Well, your Query Store data from the primary is what's being captured because that is your read-write copy. And that information gets propagated over to the secondary, right, just as any other user data would. But if you're querying that secondary, anything related to performance of those queries is not being captured in Query Store because your database is read-only. So the data from the primary gets propagated over to the one or more secondaries, but no performance data is captured on the secondaries. Now, looking at that Query Store data is something that you can do in Management Studio using the UI. There are 6 different reports that are provided within Management Studio, or you can query that data directly. Now, in terms of the data itself, hang on one second. I want to make a quick change to one of my demos that's running. So one of the things that I do in the background here is load up some data to create some interesting demos. So I just had to kick something off there. But back to the data itself and what we see in Query Store. If we think about the DMVs that we use currently to capture performance metrics, right? We think about DMExec query plan, DMExec cached plans, and DMExec SQL text. From these 3 DMVs, we're pulling the text of the query and the plan for the query. Now, we can also get the plan in Management Studio, right, if we capture the estimated plan or the actual plan when we run the query. But typically, I think a lot of us pull the plans from these DMVs. And that information gets stored in what I call the plan store. So the query store is all that information. And sometimes you'll hear the folks from Microsoft say query data store, and you'll see abbreviations of QDS internally in some of the memory clerks or in the extended events. And within that query store, I kind of break them out logically into the plan store, which has the plan and it has the text of the query. And then we have our execution statistics. So the information that we might capture from DMExec query stats, or that we might aggregate using SP statement completed or SQL statement completed, those extended events, that information exists in the Runtime Stats store. So this is where we find information about query performance. And I will say Runtime Stats and I will say Execution Stats. They're the same thing. I use them interchangeably. And then if we were interested in wait statistics, we might pull information from DMExec session wait stats, which would be specific to the wait statistics for a given session. And that information is stored in the wait stats store portion of Query Store. And it's important to know that that wait stats information is specific to SQL Server 2017 and Azure SQL database. So that hasn't been ported back to SQL 2016. You're only going to see that in SQL Server 2017. If you think about query execution and wonder where Query Store fits in, this graph kind of explains that, not this image explains that. So if you start at the top here where we talk about query execution, right? When you submit a query to SQL Server, every single query has to have a query plan generated. And so there's a lookup to say, okay, does the plan for this query exist within the cache? And if it's found there, then we're going to grab that plan. If we don't find that plan in cache, then we'll go through compilation and optimization. And at this point, if there is any plan forcing that's occurring, there's still a verification that that plan is valid here, and there's a check for a recompile. And at this point, before the query is actually executed, you'll see here in the center, in this white arrow, that the text and the plan get sent over to Query Store. So before the query finishes executing, right, but after compilation and optimization has occurred, that query and that plan get sent over to Query Store. Then concurrently, the query is getting executed, and then when it completes execution, then those execution statistics get sent over to Query Store as well. So this is a continual process, right, that occurs within SQL Server. And so let's take a look then at what data we get within SQL Server. Does anybody have any questions so far? I'm going to assume we're good. So let's take a look at our demo. Maria, are we good?
Yeah, we're good.
Okay. So within Management Studio, if we look at the databases that we have here, you'll see that I have a good old copy of AdventureWorks, and I have a copy of the Wide World Importers database. And let me make sure that I've got Zoom It running in case I want to zoom in on anything. So if we look here at AdventureWorks, you'll see that these are the folders that we're familiar with. But underneath Wide World Importers, you should see that we also now have this Query Store folder. And that's because I've got Query Store enabled for the database, or this would also show up if I'd had it enabled previously, even if it wasn't active. And so if I expand this, then I can see that I have those 6 reports that I mentioned earlier, which we can use to look at what's happening within Query Store. So from here, if I just said, okay, what do I have with my top resource consuming queries, right? These are my queries that are really not performing that well. And by default, we're only going to look at this information for the past hour. So if you look at the top, we're only looking here for the last hour ending at 4:20 p.m. And I can change this view if I want. So over here on the far right, I have a configure option. And on this instance, I am running SQL Server 2017. So if you're running 2016, this might look a little bit different to you because I have things like log memory used, temp DB memory used, and wait time. And this information isn't in 2016. So this is some new information available only in 2017 in Azure SQL Database. But by default, we are looking for consumption based on duration and total duration for the last hour. But I can change this, right? If I were interested in just looking, let's say, for the last 30 minutes, I can change this view so that it's only going to display that data. So when we look at this, what are we really seeing in this window? Well, in the top left over here, we have the different queries, which it doesn't look like that because it's just a bar graph. But if I hover over one of these, then I can see information about the query. I get the ID, this total duration, the total execution count, and the plan count, and I also see the query. But I'll be really honest with you, even though the bar chart is nice because I get a visual of what's really performing poorly, right, this first query here, I don't love that I have to hover over the bar in order to see the information. And that's okay because we have a different view option. So if you look at this icon right up here in the top, if I click on that, it changes it to a grid view, which I prefer because now I can see the query text right here in this window. I can expand it if I want to see more. I can see the name of the object, the stored procedure here. And if I scroll over, I can see the number of plans. And I can sort on these columns as well, which is kind of interesting. So if I sort on, let's say, this one, which has a plan count of 2, when I highlight that row, then the view on the right changes. And so what I see over here on the right is I see the plans that are associated with my specific query. And I have 2 different plans here, right? Plan ID 8247 and Plan ID 8257. And when I click on these, in this first one on 8247, I have a clustered index scan that feeds into a stream aggregate. But on my second query, my second plan for that same query, which is 8257, this is an index seek with a key lookup. So I have a parameter sensitive query here, right, that has generated 2 different plans. And so the different IDs are represented and the plans show up with different colors, and those colors don't mean anything. It's just a visual to separate the 2. They're not the same in between views, right? They'll change. But what we're looking at here across the bottom is our time metric. And then on our axis here, we're looking at our total duration. And this might change, right? If I changed and said to, let's say, CPU, and I was looking at average instead of total, right? These points might change a little bit. But here we can see that the clustered index scan performs worse in terms of average CPU than our index seek with a key lookup. And so again, I can highlight the different queries, and here for this query for our stored procedure of find order by description, I see that I have the same plan, 8252. Query performance has varied a little bit in terms of average CPU, but again, I'm looking at this over time. Now, I should, if I've prepped my database correctly here, I should be able to look at this information across a broader window of time. So for our demo, I'm typically just showing you a short window of time. But I have taken a database and populated a bunch of query store data over time so that you can get a better idea of what it's going to look like in your environment. But it does take a little bit longer to load that information up, because it has to read that from disk, right? Because it's just like any other internal table where the information is persisted in a table on disk, and it has to be read from disk into memory. So I'm going to let that load for a minute, and while that loads, I'm going to switch over to my query, and these are the system views that underlie all of that data. So it's important to make sure you're in the context of the user database, because otherwise, if you default to master, you're not going to have any query store data in master. And believe me, I've run that query many times. So we have two objects, query store query and query store query text. And this stores slightly different information in that in our query store query text, which is our second set of output here, we have the query itself, and then we have the text ID for that query. So this is unique, right? Every single query has its own unique query text ID. And then if we look up here in our top window, and again, this is the output from query store query, here we have the relationship between the query text itself and then that unique query ID. And you might wonder, why do we have a query text ID and why do we have a query ID? And one of the reasons is because there are these context settings, which this is something that I think is really cool that gets captured. If you think about the context settings for Management Studio, like arith abort or ANSI nulls, right? Those have a default value. And when you connect with your application, you may, not you, maybe your developers may use the same values that you use in Management Studio, but they may not. So I've had the scenario where I have a user who says, well, when I execute this query from the application, it's really, really slow. And I'm like, well, which one is it? And so then I come and I run it in Management Studio and it runs just fine. And the difference there is the context settings. And so that gets stored here in the query store text view, which means that I could have the same query text in here multiple times, but with different context settings. And this view includes a lot of other great information like the query hash, if there's any query parameter going on. And then as we scroll over, you get information. And if we come over here a little bit further, we got as well. So information specific to compilation and optimization is stored with that query text. So this right here, those two views, along with this query store plan, that's the information that gets sent over right away, right? The query information and the plan information. And the plan, every single plan has its own plan ID, and then it gets tied to a query ID as well. And because a query could have multiple plans, it's possible that you could see multiple query IDs in here, the same query ID in here multiple times with different plan IDs. Now this is great because you'll notice here it captures the engine version, and you'll see I have a couple different engine versions here, which means that I can use this for testing my upgrades, right? I can look at a plan in a particular version and then I can back up that database. I can restore it to a new updated version of SQL Server and run my queries there. and look to see if I have a difference in plans between versions. I also have the compatibility level. So I can do some compatibility mode testing, right? If I'm looking to see if there's issues related to compat mode or also to the cardinality estimator version, I can use Query Store for that information. Now, separate from that query text and the query plan, then I have the runtime stats information. And if we look at this here, just how we see it within the Query Store, the runtime stats are tied to a particular plan. So here we've got plan ID 1, and we have different runtime stats IDs and runtime stats interval IDs because our runtime statistics are tied to our plans for different windows of time. And so if we start to scroll over to the right, you'll see, well, how many times did our plan execute within that time period? And for that, what did we have in terms of duration information? And you'll see we get average, maximum, standard deviation. And we get this not just for duration, but also for CPU, if we scroll over, right? All of those options that we had for selection within the UI for that top resource consuming report, this is where that information comes from, right? From this runtime stat store. So we also have logical, and then we have writes, and all of those other resource options are provided here. And so finally, the last one I want to look at is the weight statistics, because the weight statistics are also tied to the query plan. So if we execute this, this starts to look a little bit messy, and I'm not going to let it fully complete. But our weight statistics are tied also to our plan. So let's look here at plan 42. So for plan 42, you'll notice that we have multiple weight stats IDs. And if we look at our weight categories, right, you'll see that we have different weight categories because here within Query Store, these weight statistics are stored for a particular plan for a particular window of time. Now let's hop back for a second to look at our resource consuming window. So I was looking just at those individual views. Obviously, when we look here in the UI, it's pulling the information from the Query Store query text view and also Query Store query. And when I highlight this, let's just use this one as an example, right? This is a Query Store query actually, and you'll see that it has multiple plan IDs. So this is something that you can expect to see potentially in your environment depending upon how much variability you have in your plans for your queries. And we can look at this over time, and we can see that between the 14th and the 20th, we had some variability in terms of what plan was being used and how those plans performed. And currently, we've got 2 of those plans that are being used again. But in your environment, this is what you'll see, potentially, right, depending upon what you've got for plans. If you have a more ad hoc environment, you can probably expect to see this type of variability. If you've got more stored procedures where they're pretty consistent, right, you might see something like this, right? I have 2 different plans, plan 45 and I have plan 1882. And so these are 2 different plans, a clustered index scan and an index seek with the key lookup, but we see kind of a pattern in terms of what's being used at what time. And again, this gives us our duration across the x-axis, and the y-axis is giving us, in this case, our average CPU time. Do I have any questions before I go through the rest of my statements?
No, Erin.
Okay. So I have a few other queries where I start to pull all of this together, because obviously when we're looking at this query performance data in this window, it's pulling from multiple views to look at that information, and we want to be able to do the same. And I give you both because this is a really great place to start, but sometimes we don't see everything that we want to see in this output, right? In this grid view that we've got right here, it's great, that I can see the query ID and the object and the query text, and I can see some performance information, but I don't have anything like the version on which it was run, or the pat mode. And so then I have to start writing custom queries. So this first one just goes against query store query and query store query text and pulls compilation and optimization information. And so if we run that, and I have a fair bit of data here, and I'm not really running it with a where clause, so we return a lot of data. But here I can pull all of that data together to look at compilation information. If I want to expand this out and look at my query along with my plan and my runtime statistics, and I want to do this for a specific query ID, what I'll do is I'll grab that query ID from here. So we're going to grab query ID 45 because that's got some interesting data here. And we'll run that. And notice that I've got the query plan in here in two ways. By default, this is stored, or sorry, not by default, this is stored as an nvarchar max. So if you want it to be a clickable link, you've got to convert it to XML. So we'll execute this. And now we can see that for our particular query, we have our plan. And we actually have two plans for this, right? If we scroll on down, but for our different windows of time, we can see how many times that query executed, what the average duration looked like. And if I come over here, I've got the plan, which I put up. So here, clustered index scan that we were looking at within the UI. And if I scroll down, let me come back here to the first part. So we were at plan ID 45. And if I scroll further down, so if I look at this plan, this should be our index seek with lookup, right? So I'm just pulling that same information. Instead of you looking at it in this view here, we are running queries to pull and look at it within Management Studio. And of course, if I wanted to say, okay, let me see the queries that have executed in the last 8 hours that have more than one plan, what do I see? Well, this was one that's of interest to me because this is a query that's coming from my application. Okay, so for this query, then I can see that I have more than one plan. And if I want to look at the different plans that exist, I can input that as well. So obviously, using the T-SQL is a little bit more manual. It requires understanding how to write the T-SQL and the views underneath, but you get a lot more flexibility in terms of the data that you can pull back. And I only showed you top resource consuming queries, right? There's other ones here that might be of interest to you, like what queries have regressed, what do we have in terms of overall consumption, and then also what do we have with queries that have a lot of variability. So these are built into Management Studio, and note that depending upon the version of Management Studio you are using, you may see a different number of reports. So if you're running anything below a 17, the current release for Management Studio is 17.5, which is what I'm running here. If you're running a 16X, you will only see 4 reports. 17.1 introduced all of them. And there was a bug in one of the Management Studios where the regressed queries didn't show up. But know that you can right-click and you can still view that information this way. So I recommend running the latest Management Studio if you can. All right, so I want to talk a little bit about the runtime statistics because I've mentioned these and I've mentioned intervals of time, but I haven't really explained that. And I'm a very visual person, and so I think that this is one of the easier ways to get that. So we have a query, right? Our select from the sales orders table based upon customer ID. And we've got the query store query table, which I mentioned, or it's a system view, right? There's an underlying table. And that has an ID of 786 for this particular query. And then in query store query plan, we have a plan ID, which is going to be 805. Now our runtime stats, the first time we execute that query, we get an entry into the runtime stats view, which is for this specific plan for a particular ID, where the ID represents an interval of time. So the first time it executes, we get this information, and our duration data is just what I'm using as an example. Remember that we also have logical reads, physical reads, writes, tempDB, all of the same average, last, max, min, standard deviation for those. But we're just going to look at duration. So the first time it executes, it takes 400 microseconds because, by the way, the duration data is stored in microseconds. Now, the second time that it executes, it takes 800 microseconds. So then my totals here get updated. So my average duration goes up. My last duration is set to 800. My max is 800. My min stays at 400. It executes a third time, and it takes 500 microseconds. So the average adjusts, the last adjusts, right? My max and my min are still the same. And I executed a fourth time, and it takes 300 microseconds. And so the numbers adjust again. And this continues until that window of time, that time interval, ends. And then after that window of time ends, on the next execution, I get another entry in Query Store Runtime Stats for that plan ID. But notice it has a different interval ID because it's the next window of time. And for that first execution, it took 350 microseconds. So you'll get, which we saw, multiple entries in Query Store Runtime Stats for a given plan for the different intervals. So now let's talk about these intervals. So for an interval of, let's say, 2932, right, within our Query Store Runtime Stats interval system view, there'll be a row with that particular ID, and it will say that our start time was December 6th at 12 p.m., and the end time was December 6th at 1 p.m. So anything that we see in Query Store Runtime Stats for an interval of 2932 represents 12 p.m. to 1 p.m. on December 6, 2017. And so in that time window, that plan, 805, executed 4 times. And then for 2933, that interval represents 1 p.m. to 2 p.m. on December 6th of 2017. So the query only executed 1 time within that interval. So now that runtime stats interval is something that you can configure. So let me show you where that is really quick here, because this is something that people ask about a lot. So within the properties of our database, if we come in here and we look at Query Store, right, you'll notice that this is an option that you don't have prior to 2016. So within Query Store, we have our operation mode set to read-write, and we have this that's hard to say, statistics collection interval here. Now, I have it set in this database to 10 minutes, but it defaults to 1 hour, which is what I was just using in the example. So by default, when you install Query Store, that collection interval is 1 hour. So your runtime stats intervals will be 1 hour periods, 1 to 2 p.m., 2 to 3 p.m., 3 to 4 p.m. You can change it, as you can see here. You can only change it to certain fixed values. Do you need to change it? Well, that's really going to depend upon your workload. And I wrote a blog post that talks about all the different settings that you see here and what their defaults are and what considerations you might have if you change them. And in terms of that interval, I know that there are performance issues that can happen within a 5 or a 10-minute interval that won't show up in an hour's worth of data because there's too much other data that will offset my 5 or 10 minutes of poor performance. If your system is prone to that kind of situation, if your system is, let's say, not very stable and you have performance issues and you're really trying to pinpoint what's going on, you might want to set it to a smaller value like 10 or 15 minutes. I don't know that I would recommend 5 minutes. I know I would not recommend 1 minute. These intervals are extremely small, and they are definitely going to affect how much space you need to store that Query Store data. So I would go to 10 or 15 minutes if you are definitely a system with performance issues. If you're not, or if you're not sure, then maybe you go to 30 minutes or maybe you leave it at an hour. In the customer environments that I work with that are remote DBA customers, I tend to set it to 30 minutes. I haven't dropped down to anything lower at this point. But understand that if you set it to a lower value, then you're going to have more interesting data points, more discrete data points about performance, but you're going to have more data, which is going to affect how much space you need, which is set right here with your max size. So you decide how much space you want to allocate to Query Store. And once it hits that limit, it will, by default, start to age out the oldest information. So you want to make sure that you set this appropriately. And the next question you might have is, well, what do I need to set it to? And of course, that depends on what you have set for that collection interval. And it also depends on your workload. So if you have a lot of stored procedures and a lot of queries, the same queries that get run over and over and over again, you're not going to have as much uniqueness in terms of your queries and your plans, perhaps. But if you have a wildly ad hoc workload, and I think of something like Entity Framework or nhibernate or Hibernate, right, that can be very interesting in terms of the queries that get generated, those workloads are going to require a lot more space because the same queries are not being executed over and over again. Now, in terms of query regression, because this was one of the other big benefits of Query Store, is that let me see which queries are not performing well right now, and let me see which queries have regressed, which queries are not performing as well as they used to. And this gets calculated using the values that are in Query Store and displayed to you through the regressed queries UI. And you can also query those views directly. So let me hop back over to take a look at this. And sometimes with this demo, I don't always get the output that I expect. So let's see what I have here. Oh, it worked. That's always nice, right? So here we can see that for this given query, it's telling me that performance has degraded in the last hour. And when it's looking at regression, it's typically actually looking at CPU if it's looking at forcing plans. But in that particular view, if we just go into regressed queries, it's looking at duration information. And in terms of our configuration, it's looking at the last week compared against the last, it's looking at the last hour compared against the last week. So it's using information in Query Store and doing a comparison across two different windows of time, those runtime stats intervals that I showed you in the PowerPoint. Now, this is funny because I don't have anything, right, from last week. But if I said, okay, do I get anything from last month, I may or may not get anything here, right? So we can see that different queries, this is a great example. This isn't one of my queries, but for purposes of example, that's okay, right? We can see that this query back at about February 17th was performing with with a total duration of 200 milliseconds. And now when we look at that, it's at 1600 milliseconds, right? So the regression compares query performance from one window of time to another window of time, which you can configure here. So when someone comes to you and says, hey, we had a horrible performance yesterday afternoon, and you're like, okay, you can now go and select for your history yesterday afternoon's time period, whatever it was, and compare it against a previous time period or what's performing right now. So the regress queries is kind of cool because it allows you to compare different windows of time. Now you can write your own queries to look at that information as well, going against those views. It's completely up to you, depending upon what, again, is of most interest. Now, a couple notes about plan forcing, right? This is not the same as a plan guide. So it's not a replacement for a plan guide. It is a different entity. And so with Query Store, you have the ability to find a query that's got multiple plans, and we've seen that already. And then you can force a specific query to be used for, or excuse me, force a specific plan to be used for that query. And you can do that in the UI, and you can also do that with T-SQL. And my recommendation would be to use the T-SQL because I know you all have change control, and then it can get logged in change control. But if you don't, then maybe the UI just works fine. Here's the thing about plan forcing. I view plan forcing as a temporary solution. I don't think that you force a plan and expect that you're going to be forcing that same plan a year from now, right? If you've got a poor performing query, the ideal solution is to address the code or to address the schema and to try to address it that way. But we can't always do that quickly, and we need to stabilize plan performance, so that's why we can force a plan. But if I force a plan and for some reason that plan is no longer optimal, Query Store can continue to use it. So that's another reason that I don't look at this as long-term, because unless you have a method in place to go back and check this on a regular basis, you might be forcing a plan which is no longer optimal. Now, plans can fail to be used when they're forced, which is why I would definitely recommend that you use extended events here. You cannot use trace. These events do not exist in trace. You have to use extended events. And the Query Store plan forcing failed event is the one that you want to monitor. In all cases, SQL Server wants your query to execute. So for some reason, if it cannot use the plan that you have forced, it will go through normal compilation and optimization. So for example, consider that you change an index. Maybe you add a column, you remove a column, maybe you change the index name. If that was part of a forced plan, that forced plan can no longer be used in certain scenarios. If you have a query that's part of a stored procedure and that query has a forced plan, and then you make a change to that stored procedure where you drop it and then you create it, the the drop and the create changes the object ID, which means that all of a sudden that plan isn't forced anymore. So to force a plan, I'll show you how to do this really quick. What we do here within, let me get this into the grid view and let me see if I get anything that's of interest here. It's got multiple plans. That's one of my queries. No, that's okay. We'll force one of these. Here we go. So let's say that I have this query and I've got my two different plans that exist, and I have, after realizing it, 2 weeks later, geez, this is the one that I really want it to use. All you have to do is click on this force plan button. It's really easy, right? My mom could do this. And so when I force the plan, it says, do I want to force this specific plan for this query? And I say, I do. And so what you see now is when you look at that particular plan ID, you'll see that it has a checkbox, which means that that plan is forced for that specific query. And the easiest way to find these is to go into my queries with forced plans view. So this is an easy way to see, okay, what queries have a forced plan? And if I have more than one, obviously I'll list them here. But again, this to me is a temporary solution. It's not something that I'm going to do long term, and I need to make sure that I pay attention to the performance of that forced plan over time. Okay, so we've talked about a couple uses of Query Store here in terms of looking for regressions in our performance, figuring out the queries that are the most expensive, and then we can look to see what do we have in terms of differences for degree of parallelism, memory grants, execution performance for a given query across different plans. And we just touched upon the ability to force a query plan for a specific query. We can also use this for testing, which is where if you've been tuning for a long time, right, you look at Query Store and you're like, wow, I have a baseline built into my system, right? Now, if you have a third-party tool, you might already have a baseline. That's great. But for those of you that don't have a third-party tool that might have tried to create your own method for capturing query performance information, you know that it's not really that easy to do. And so Query Store has all of that built in. So I can test and upgrade before I actually upgrade the system, right? I can test changes in the cardinality estimator before I actually change that permanently or before I upgrade. So in both these situations, upgrading the cardinality estimator, you back up that database, you restore it on another instance, you set the compatibility mode, you set the cardinality estimator, you have the new version installed of SQL Server of your application, and then you run your queries, and Query Store continues to capture information. Now, comparing that data is a little bit more of a manual effort, but it's all there. You didn't have to set up a method to capture it. It's part of Query Store. You can go in and figure out how to compare query performance before and after. So if you're interested in some more information, I've got a blog post on the Query Store settings, which I mentioned. I've got a Pluralsight course, which is an expansion of what we've covered here. It's about 2.5 hours of time. There's a couple Connect items here, and I did finish, I need to update this, I did finish a Pluralsight course on automatic tuning, which uses Query Store under the covers in 2017 and in Azure SQL database. So I really appreciate you guys staying with me through this whole thing. If you've got any questions or anything you want to see in more detail, I'm happy to take a few minutes and address that now.
Yes, we have questions. I can.
Okay.
This. Let me see. Hold on, Erin will try to ask questions.
Okay.
1, 2, 3.
Hi, my question is, there's a parameter there when you're on a database, right, and you go for the priorities, the properties, sorry, you get to see for the Query Store, there's the flush something, data flush interval. So what is the recommended here? And it says 50 minutes. Does that mean that only after 50 minutes you get to see the data inside?
Good question. Let me pull up another slide deck that has a visual that will explain that in a little bit more detail. So here are those internal tables within the Query Store database. And I talked about the different logical ways that that data is broken up. And I talked about how when you submit the query to SQL Server, you have compilation and then you've got execution, and then that information is set over to the Query Store. What I didn't tell you is that that memory is in memory temporarily, because consider the cost to SQL Server of every time you execute a new query or every time a query completes that it has to write data to disk tables, right? Very expensive. So the optimization here is that the information is being held in memory and it gets flushed asynchronously to those Query Store tables. Now, that setting that we looked at here, the data flush interval, that determines how frequently the data gets flushed from memory out to disk. But when we query Query Store, it reads the memory that's there, it reads the information that's on disk and it reads the information in memory, and it does a union all between that, so you still see it. So the default value for this data flush interval in minutes is actually 15. I've set it to 50 here for some reason, but the default is actually 15. And if you look at the blog post, my recommendation and the recommendation from Microsoft is to leave it set at that, to not set it any lower. Because again, when you're querying the data, it's going to read from both memory and disk, and it's going to present that. And it could flush data to disk more frequently as an optimization if it feels it needs to.
Another question. So the data is written into a wide world importers database in that case, right? So
Correct.
Into which file group?
Primary.
Okay.
Because it's a system table. And currently there's no way to change that.
One more question.
Mm-hmm.
The data between restart all the internal tables data after restart the service?
Right. So because it's persisted in internal tables, it persists between restarts. So when you go to shut SQL Server down, it does a flush of whatever's in memory and flushes that out to disk, so that gets written to the internal tables. And then you restart, and that data, some of the data gets loaded again into memory after a restart because it needs that information as it starts to work again. So it loads information into the query store memory clerks and then continues to use that. So it persists between restarts. And again, if you have an availability group, it's going to exist in the secondary copies of the database. If you had mirroring set up, right, we know that mirroring is technically deprecated, but it works. If you had mirroring set up, that information would get propagated over to the mirror instance. Log shipping, same thing, because it's part of that user database.
Okay, and one more question. Do you have any real example when SQL didn't choose the optimize plan and you have to pick up that force plan to, because as I know, every time we choose the optimizer, the best plan. So I've never seen such an example where there were two different plans and he didn't choose the best one.
So let me make sure that I understand your question. You're saying, is there a scenario where I have a query that has multiple plans and I see that in the real world and I want to force a particular plan for one query? Is that what you're asking?
Yes.
Okay. It does happen, right? There are the best thing that I can show you, I can't pull it up again quickly, but I have seen multiple queries that have multiple plans where when the plan gets flushed out of cache, either because of a stats update or there's a schema change for some reason, or there's a restart, right, where a different plan comes into cache, then performance tanks, right? And this is a very common problem where all of a sudden performance is fine and then for whatever reason the quote-unquote bad plan gets into cache, and then somehow people think it's a stats issue, so they update stats, which forces a recompile, and then the quote-unquote good plan comes back into cache and everything seems fine. Query Store is targeted for that type of problem. Now, I gave a very simple example where I had two different plans for one specific query. But very often there's 5 plans or maybe 10 plans, and the limit by default is 200 different plans for a query. And I thought, who in the heck would have 200 different plans for a query? But I talked to somebody at SQL Bits that had over 5,000 different plans for a query. So it can absolutely happen depending upon your data, depending upon the tables involved in the query, depending upon the input parameters. And so the plan forcing is our best effort at creating plan stability, query performance stability by forcing a specific plan. Did that answer your question?
Yes, we have another question?
Another question. Suppose I have a stored procedure. That procedure has like, let's say, 10 queries, okay? And how exactly do I know that a certain query came from a certain procedure? Is there a way to see it?
So when you look within Management Studio, each one of those queries gets stored separately. So I didn't show you this because I don't always have time, but hang on. I have to demo.
It's okay. Take your time.
Here. So this procedure right here, right? Get full product info. It has 2 queries in it. And so when I run that, that's not it. I have way too many demos, can you tell? What was it? Get full product info. There we go. So now I'm running those behind the scenes. And what do I have? Let's look for the last 5 minutes here. I should see, here's get full product info. Here's one of the queries, right? But I would have, if I go, let me go based on execution count. And you can sort when you're in here. Here we go. So now I have both of these queries, right? So if you have a stored procedure with 10 queries, each of those 10 queries has their own entry in query store text and query store query, and it's tied to the stored procedure, which is why if you make changes, it's really important to do an alter as opposed to a drop and create, because it has the object ID and it uses the object ID to go over to sysobjects. And when you do a drop and create, it changes the object ID. So here I can see, okay, I have my 2 different queries for my stored procedure, and I can look to see how are these individual queries performing, right, based upon what I have here, and which one isn't performing well, which one maybe has multiple plans. Now, from here, from the UI, I don't have the ability to just see all queries for a stored procedure. In that case, you probably have to write your own query, right, to say, okay, show me all the queries within query store for a given stored procedure. But you can do that, because if we come back here and we look at what we see in query store query, you see that we have the object ID right here. So I can see what the object ID is, which means therefore I can retrieve via T-SQL all the queries for a particular stored procedure. Does that help?
Yeah, pretty much.
Pretty much. Email me if you have more questions.
No, I think we are done. Thank you very much, Erin. It was awesome session.
No problem.
It was recorded. I hope you don't mind.
Nope, that's fine.
All right. Thank you.